Yeah, good evening, everybody. It is already quite late, and I'm so happy that even at this time, the number of audience, the delegates are still there. So many of them are there. That shows the amount of interest you people have for the subject anesthesia. So today we'll be discussing, because invariably you will have anesthesia machine and anesthesia workstation will be there for your exams, practical exams. So you have to know a lot about these machine and then the workstation, so that you can answer well and then you can get more marks. And also, even in theory, you will be getting questions regarding the individual parts of anesthesia machine or workstation. So another important thing why you should know is, every day you are using this. The equipment you use, you should know about the equipment. Then only you can be safe for the patient. And if there is any problem with the equipment, so you know what is the problem, you can detect early. And I always keep telling that anesthesia workstation or machine is like your house. Like if you are a male anesthetist, it is like your second wife. So you have to look after your wife or second husband better than the first wife or husband, because you will be with this equipment for a longer period than with your first spouse. So very important to understand these things. So today we'll be discussing about the machine and the workstation. I'll be asking a lot of questions, of course. Along with me, Dr. Shaloo is there from MOSC Medical College, and we have 3 students from MOSC Medical College. So can you just introduce yourself? You can come here. You don't mind if you stand here and then answer? Come, please tell your names.
Good evening, everyone. I am Anaesthesia Work from Anaesthesia Medical College, final year PG.
What's your name?
Anaesthesia Work.
Ritu, okay.
Good evening. I'm Kiran K from MOSC Medical College, final year PG.
Good evening, I'm Anjali. I'm from MOSC Medical College. I'm a final year postgraduate.
Okay, shall we start? Okay. So, you see, when anesthesia was introduced by W.T.G. Martin, William Thomas Green Martin, to the world, that was 1846, October 16th. That date, nobody can forget, because even now we usually celebrate as the World Anesthesia Day. So when Martin introduced anesthesia, so he did not use any sophisticated equipment, isn't it? He just had a ether flask, and then he could demonstrate publicly in Massachusetts General Hospital. And for a long time, they were using only either their handkerchief or a simple Schimmelbusch mask to provide anesthesia. So now my question is, why there was a requirement of an anesthesia machine as such? What was you can answer.
Later on in 1885, they developed compressed forms of oxygen and nitrous oxide. So they needed a structure to put these cylinders on. That is why an anesthesia machine was founded later on.
Yeah, because these gases, so they were made to be there in the compressed form in cylinders, and these cylinders required some support. And also these gases had to be mixed in a particular, mixture, and then they had to be provided to or concentration, and had to be provided to the patient. So there was a requirement of anesthesia machine. So that was fulfilled by whom? Who introduced the first anesthesia?
Henry Edmund Gaskin Boyle in 1917.
Henry Edmund Gaskin Boyle, very good.
And it was taken from the American Guatemala machine, which was founded in 1912.
Yes, very good. So another question for you. What do you mean by a compressed gas?
Any gas stored in a cylinder above 40 psi of pressure at 70 degree Fahrenheit.
Yes, very good. Because this is one common question I have seen many of the examiners asking, because you will be telling compressed gases. So any gas, so stored in any cylinder at more than 40 psi at 20 degrees centigrade or 70 degree Fahrenheit. Now what we have, this oxygen and nitrous oxide, cyclopropane, carbon dioxide. Many of them are, the gases which are kept in cylinders. All of them are compressed gases? Yes, all of them are compressed gases. What about, for example, now ether is there, or some, CO-fluorine, desflurane, are they compressed gases? No, they are not compressed gases. So you have to understand that 40 psig is very, very important to know whether it's a compressed gas or not. Now we have two machines here. One an old anesthesia machine, and here is a workstation. Now you can tell me what are the difference between these two?
In old anesthesia machine, it involves only pneumatic systems.
Very good.
In modern workstation, it includes pneumatic system, electronic equipments like alarms, integrated ventilators, and monitors.
And what is most important, the difference
Fails,
between this?
Safety features
Yeah,
are
that is the most important thing, the safety features. Now, why safety features were included in modern workstation? Why they were not there in older machines? What is the importance of incorporating these, the safety features?
we don't want
What for? Safety features means what for?
we don't want to give hypoxic mixture to the patient.
Mainly to prevent hypoxic mixture being delivered to the patient. Because, lot of mishaps used to occur in olden days because hypoxic mixture could be delivered, only nitrous oxide. I still remember when I was a student, so we had Boyle Chef machines. That was my first day. I was told to, pre-oxygenate the patient. I didn't know which was oxygen, which was nitrous oxide. So blue thing was looking better. So I just opened blue thing, that is a nitrous oxide, and I was holding a mask. So I had real, scoldings from my senior postgraduates. But the first day I didn't know. But in those machines, you can still only give nitrous oxide to the patient, and you can imagine what could happen. So with the modern workstations, you just cannot do that, isn't it? So one question for you. So majority of the times, though we'll discuss about the electronic systems, the electrical systems, everything, but basically the pneumatic system is the most important thing. So how do you classify this pneumatic system?
The pneumatic system is classified based on the pressures that are there. So you have a high pressure system, an intermediate pressure system, and a low pressure system.
Okay,
So
what is the pressures in each of these systems?
in the high pressure system, it's basically from the cylinder. So you have higher pressures over there. So for oxygen, it will be 2000 psig, and for nitrous oxide, it will be 750 psig.
You
Now-
said PSIG. Is something, PSIA is also there? What is the difference?
Pound square inch gauge and pound square inch atmosphere
Absolute.
absolute. So
What
pound
is the
square
difference?
inch gauge is the measured pressure minus the atmospheric pressure, and absolute.
When you say gauge pressure, atmospheric pressure is considered as zero pressure. So when you add atmospheric pressure to the gauge pressure, it becomes absolute. So that's how PSIG and PSIA. So this is another common question we will be asking you in the exam. So good that you answered very well. So high pressure system, mainly the cylinder pressures. Okay, intermediate pressure system.
In an intermediate pressure system, what happens is the cylinder pressure further gets decreased. So it'll come down to 45 psig, and you also have the pipeline inlet, and with the pipeline pressures, that is about 55 to 60 psig. And then in the low pressure system, the pressure is further lowered, and it comes around to the outlet pressure comes to about 7 to 8 psig.
Yeah,
just something
above
just above the atmospheric
pressure.
pressure.
So very good. So this is how we classify high pressure, intermediate pressure system and low pressure system. So today, because Madam Shaloo is also there, so I'll be discussing about the high pressure system. So she'll be discussing about the intermediate system and the low pressure system. So she'll be asking you a lot of questions regarding that. So one difference I just want to ask you in these, we have the pipelines also there, isn't it? So, but here there is a separate, inlets for pipeline connection. Okay, it's on the back, definitely. But here there are no separate connections for pipeline, isn't it? So where do you connect the pipelines here? You can answer.
It is connected to the yoke assembly.
Yeah, same where we'll be connecting the cylinder, there only we'll be connecting the pipelines
Using a
also
yoke
in the
bolt.
older machines. But in newer machines, we have the pipelines have got a separate inlet, and pipelines are usually where they get connected, they are considered in the intermediate pressure system. But there is a difference between these pressures, isn't it? Because the cylinder pressures are reduced to 45 psig, whereas the pipeline is added at 55 psig. So why this difference of pressures? Why not cylinder pressures are also 55 psig and this also 55 psig? Any safety feature adopted in this?
The cylinder pressures are always high. This is because when both the cylinder and the pipeline is kept open simultaneously, the preferential gas flow should be from the pipeline. This is in order to prevent the exhaustion of the cylinders, and the cylinders are kept as backup.
Now, why preferentially the pipeline should be used? Why not the preferentially
Because oxygen
cylinder?
cylinders should be used as backup, and
Now, why backup?
at the time of emergency,
Now, what is the amount of gas you have in the cylinders, and what are the amount of gas you have from the pipeline? The total quantity.
it is
Is
high
it
in
same?
the pipeline. It's more in the pipeline.
Yeah, it is quite a bit enormous, especially from a liquid oxygen source if you are getting, or even multiple, the H type of cylinders, bulk cylinders. You have primary source, secondary, bank of cylinders. There's quite a bit. These cylinders will not have so much, isn't it? So they have to be kept as reserve, and only in case when you suddenly, the pipeline pressures drop, so you'll have to open it. So in older machine, what used to happen? Suppose I have opened the cylinders, I have also connected the pipelines to the wall outlet. Together they are there. Will there be, pipeline pressures or pipeline gases will be used preferentially, or the cylinder gases will be used preferentially there? In the older, this type of machines.
Both can
Now,
be
cylinder
used.
pressure is at what pressures?
Cylinder pressures are at 55 to 60 psi.
No, 2000. They are entering the machine at 2000 psig. Whereas pipeline pressure is entering at 55 psig or 60 psig. So which one preferentially the machine will use? Cylinders. So that is one of the problems with older machines. So that is how, that has been changed, and a separate pressure gauge and also separate inlets for the pipelines have been included in modern workstations. So that is another very important thing you should know about. Now coming to the high pressure system. So what are the parts of high pressure system?
It includes yoke assembly and
No, you can start with the cylinders,
cylinder, okay.
because cylinders are always part of the machine, isn't it? Without cylinders, you can't have the machine.
Okay.
It is always part of that.
cylinder, then the yoke assembly,
Yes, yoke
then the pressure
assembly.
gauge, and
Yes.
the pressure regulator.
Yeah, pressure regulator. Okay, these are the things. So a lot of questions can be asked for you regarding the cylinders. Now, majority of the times we'll be asking about the safety features of each one of them. So now coming to the cylinder itself. So what is the material with which the cylinders are made of?
The cylinders are made of molybdenum steel.
Yes, very good. What is the advantage of having the molybdenum steel?
has
Because
got
when cylinders were introduced, so they were introduced with only a hand-forged steel. The material with which that was made was a hand-forged steel that was in 1880s or early 1900s. So what was the problem with hand-forged steel when compared to molybdenum steel?
The hand forged steel has got a lesser tensile strength. So
Very good.
in order to make it hard, the thickness should be increased so that
Yeah.
the weight is increased and the content of the gas also.
No,
reduced.
inner quantity of the
Quantity
inner
of the
capacity also would
capacity is
decrease.
also reduced. But
So what is
using-
the increase in capacity and also decrease in weight with molybdenum steel now?
while using molybdenum steel, the capacity and the weight capacity increased by 20% and the weight also reduced by 20%.
Yeah. Any other material that is being used for manufacturing cylinders?
Aluminum can be used.
Yeah,
In
aluminum
case of
where
MRI
we use-
compatible cylinders are used with aluminum.
Yeah, for MRI, you cannot use the same molybdenum steel. High tensile strength, isn't it? So that is another advantage. So you can tell me what are the safety features that are there in the cylinders? Because cylinders usually has a cylinder body. So this is the cylinder body and you have a separate cylinder valve, isn't it? Body and a valve are there. So what are the safety features in the body?
First of all, the cylinder has a seamless body.
Yes, what do you mean by seamless?
That it means without joints. So when
Without joints, very
when
good.
it's seamless, it won't
Now
get
why it should
pressurized
not
at
have a
any-
joint?
so that it doesn't get pressurized at the constructions.
No, that will be the weakest point. If there is a joint, that will be a weakest point, it will open up, isn't it? So that's how the joint should not be there. That's why cylinders are made in such a way that they don't have joints. That is what is called as seamless. That is what first thing you'll have to tell about. Okay, then.
Then it has pressure relief
No,
pressure relief valves,
that is in the cylinder valve. I am asking about the body of the cylinder.
color coded.
Yeah,
Oh,
color coding.
And then it's made up of molybdenum
No,
steel.
when
which
this
is
color coding was introduced, it is called as international color coding.
International color coding was introduced in older one was introduced in 1949,
Yes.
and the newer one was introduced in 2010.
2010.
In
Okay.
India, we are following the older one.
Yeah, why color coding should be there? What is
Color
the
coding should be
advantage
there
of?
because we're using different gases. So in order to identify what gas is being used, we need to know where that gas is being placed. So in order for that, we need color coding. So it
For identification of the gas contained in that particular cylinder, isn't it?
Yes, sir.
Okay, now what is the color coding for oxygen and then color coding for nitrous oxide?
For oxygen, the body will be black and the shoulder will be white.
Okay.
For nitrous oxide, it is body and shoulder will be made of French blue.
French blue, very good. So for
then-
carbon dioxide?
For carbon dioxide, body and shoulder will be gray.
Gray.
For air, the shoulder will have black and white stripes and the
Very good.
body will be black.
Okay, helium?
And for helium, it will be brown. The body and
Brown.
shoulders will be
Okay,
brown.
because these are some of the cylinders what we'll be using. So now what is the 2010, the updated or modern international color coding has been introduced.
In the international color coding system, first of all, a capital letter N will be there on the cylinder to
Okay.
say that it is
Okay.
it is based on the
Right,
international
very good.
system. And the body for all the medical gas cylinders will be white.
White, very good.
And the difference is only in the shoulder. So for oxygen, it will be white itself.
Okay, okay.
For air, it will be black and white
So you
shoulders.
identify the gas by looking at the shoulders.
Shoulders.
Otherwise, bodies of all medical gas cylinders are made of or colored white only. So that is how you have to know about. But of course, in India, we have not yet started using this particular color coding. So now coming to the cylinder valve. So you can answer about cylinder valve. So what are the safety features we have in cylinder valve?
We have a pressure relief devices
Okay, pressure relief device. Why should you have a pressure relief device?
because
Suppose I keep this cylinder while transportation, the cylinder has been kept in sun, under the sun, and it gets heated up. So once it gets heated up, so what can happen to the gas inside?
according to Charles' law, the volume is directly proportional to temperature when the pressure is kept constant. So
Okay,
when
okay.
in the
But
sun
here,
the temperature increases.
Is it Charles' law or Gay-Lussac's law will be applied?
first.
Because
Since
our
the volume
discussion
is
is also
constant.
our discussion is also some relevance to the gas laws also today. Okay, what is Gay-Lussac's law?
Gay-Lussac's law states that the pressure will be proportional to the temperature when the
Temperature.
volume is kept constant. Since
Okay, now
the-
here the volume of the volume inside is kept constant, isn't it? Because good tensile strength is there, so volume cannot change. So temperature and pressure are directly proportional to each other based on Gay-Lussac's law. So what will happen to the pressure inside?
when the temperature increases in the sun, the pressure increases and it will expand.
Normally, what law is applied? Now there is a compressed gas is there. What law is applied there?
Now Gay-Lussac's law.
Now, for example, now the gases are there. They are under high pressure in a small volume, just 5 liters volume, but so much of high pressure, 2000 psi. What law is applicable there?
Boils.
Boyle's law, because temperature is 20 degrees, temperature is kept constant, but high pressure gases in a small volume. So volume is inversely proportional to
Pressure.
the pressures. So now once it is heated up, now the pressure starts building up. Even the temperature can start increasing inside, isn't it? So you said some pressure relief devices are there. So what are these? Single type of pressure relief devices are there? Multiple types are there.
Multiple times.
Can you just mention about these?
First one is the ruptured disc. There is
Okay.
a disc which is made up of copper,
Copper.
which gets a rupture when the pressure increases inside the cylinders.
A particular critical pressure is reached, so it ruptures and then opens up. So
Vents
venting
out
of
the
the
excess gases.
gases, extra gases will be there, so that there won't be any explosion or breaking of the cylinder. Otherwise, there can be serious damage. Collateral damage can occur. It can act as a missile. The cylinder can just fly, isn't it? Because of that, and explosions can occur. Okay.
Second one is a fusible plug. It has a woods alloy, which is a mixture of cadmium, bismuth, lead, and tin.
Yes, very good.
And this melts at a temperature of 150 to 170 degree Fahrenheit.
So if you convert it into centigrade, 70 degrees centigrade. At 70 degrees centigrade, the wood's metal melts. So that again, the gases are
Releases,
vented out. Okay, so
And there's
very
a
good.
combination of both rupture disc and the fusible plug. And the last one is a pressure relief valve, that is spring loaded valve. And when the pressure increases, the valve is opened and the excess pressure is vented out. And when the pressure comes down, the spring comes back to its
Yeah,
seat.
that will be like what
Can
we
be
use
reused the
cookers in our houses. So there you need not have to change the cylinder.
But the
Whereas
disadvantage
with
is
the
that
ruptured disc and the fusible plug, so because you have to, actually send it back to the factory to get the cylinder valve repaired and then changed it and reintroduce that pressure relief device. But if it is only a pressure relief valve, so it again occludes, isn't it? So then you need not have to change. But that is the best thing, isn't it? But why we
there
are
is
not
a
using
chance
that?
for malfunction.
Yeah,
High
because
chance for malfunction.
we hear or we read in papers also explosion inside the kitchen. So deliberate or accidental, we don't know many times, but that is a possibility there. So that's why we hardly use this. Majority of the times it can be a combination of ruptured disc and then the fusible plug. So that is one of the safety features that are there in the cylinder valve. Okay, any other this thing?
Pressure relief valves are there. Then in Indian cylinders, we use woods alloy in between.
In Indian cylinders, do we have this pressure relief device?
Pressure relief devices, we don't have that. But
Where usually it will be there in a cylinder valve.
it is present as woods alloy is present in between the screw threads of the cylinder
No.
valve.
Normally, where
Normally,
these devices are present.
Normally, it is below the
Conical depression. Conical depression is away from the machine or towards the machine?
away from the machine.
Away from the machine. Okay, that's conical depression where your retention screw,
retaining
tip
screws
of the
are-
retention screw goes. Just below that, this device has been incorporated. But in Indian cylinders, even if you search, it will not be there. So what other method is used in Indian cylinders to wave off this problem of
In Indian cylinders, the cylinder valve, the screw threads between the cylinder valve and the neck of the cylinder, woods alloy is used. So when the temperature
is
increases,
filled. Woods alloy is filled.
Woods alloy is filled. So
Okay.
when the temperature is at the level of 150 to 170 degree Fahrenheit, it will melt and the content vented.
Okay, vented out. Okay, that is one of the very important safety features. So any other safety feature there in the cylinder valve? You can, for example, now color coding is there. But can I still connect a cylinder, for example, oxygen cylinder onto the nitrous oxide yoke?
No, it has got pins.
Yeah,
It has got holes over the pin index.
yeah, pin index safety system is there. So when it was introduced, pin index safety system?
It has introduced in 1952 by Philip Woodbridge.
Woodbridge. Yes, very good. Because why I am asking about Philip Woodbridge and all these people. So many of the examiners are very fond of history. So they think that you don't answer that particular question. So if you answer even that particular question regarding the history, probably your marks will go up. So Philip Woodbridge introduced in 1952. Commercially, they were available from 1956. Okay, what is this pin index safety system?
It helps in fitting the cylinder correctly, placing the cylinder to the correct yoke assembly.
Okay.
So it orients the cylinder to correct place and it provides a leak-proof
No.
connection. Okay.
Pin index safety system only to see
Oh,
that
sorry.
yeah, you don't connect a wrong cylinder to a particular yoke. So that is the main thing, because just color coding is not enough. That's how these things were introduced. Pin index safety system. What is the pin index for oxygen, nitrous oxide, and air?
For oxygen it is 2.5, nitrous oxide it is 3.5, and for air it is 1.5.
1.5. So 5 is common. So 1.5, 2.5, 3.5. Just remember about that. 1.5 for air, 2.5 for oxygen, 3.5 for nitrous oxide. So it is easy to remember. So another very important thing many times they'll ask you is regarding the measurements of these pins, the holes that are there in the pins are there on the yoke assembly, whereas holes are there on the cylinder valve, and depth of them, and also where exactly they are placed, and what is the diameter of these holes.
Okay, they are the holes of the pin index system is drawn is at the distance of 9/16 of an inch.
From where?
From the port.
Port. What is this port?
port is the through which the nipple of the yoke assembly is connected, through which the gas enters
Yeah,
the system.
gas comes out of the, once you open the cylinder, so the gases will come out through this. Okay.
So the diameter of the pins is about 4 millimeter, and the diameter of the holes is about 4.75 millimeter. And the
4.75,
depth
very
or
good.
the length of the pin is 6 millimeter.
Okay, okay, okay. So pin index safety system is very important. Many times it has been asked as short notes also. So you should know more about this pin index safety system. So one more question for you is, oxygen exists here in gaseous form or in a liquid form?
Gaseous form,
Yeah, nitrous oxide.
liquid form.
Yeah, why oxygen exists as a gas? Why nitrous oxide exists as a liquid at room temperature?
Oxygen, it exists at a critical temperature, above the critical temperature of about minus 108 degree.
Minus 118.
Minus
The critical
118.
temperature of oxygen is minus
Minus
118.
118.
Okay, critical temperature of nitrous oxide?
It's room.
What is the body temperature?
36.5.
Yeah, 36.5.
So it remains in the liquid state.
Yeah, what is critical temperature?
Critical temperature is the temperature above which the it cannot be
Compressed
it
into a-
cannot be compressed into a
its liquid state.
liquid state.
Isn't it? So because of that, nitrous oxide being its critical temperature is so high, at room temperature it exists as a liquid.
Liquid.
For example, now the temperature is increased of nitrous oxide to 40 degrees. So what will happen to nitrous oxide? Can it still remain as a liquid?
No, it will start vaporizing.
No, it will get converted to gas.
It'll
Anything above 36.5, it
get
cannot
converted
remain
to
as a liquid with whatever the amount of pressure you apply, it can remain as the liquid only, isn't it? Now, we have pressure gauges here. We have pressure gauges for nitrous oxide, we have pressure gauges for oxygen also. Now, which pressure gauge will represent actually the contents of the cylinder? How much the content is there regarding nitrous and oxygen?
nitrous
Because nitrous oxide is existing as a liquid.
liquid.
And what is the pressure gauge is showing there is what actually?
It shows the amount of nitrous oxide that is there, but in the liquid form. And until
No, no,
all
no.
of the
What
liquid
pressure you are getting? Suppose I open the pressure gauge of nitrous
vapor
oxide.
pressure. For nitrous oxide, it is a vapor pressure.
Saturated vapor
saturated
pressure.
vapor pressure.
Isn't, what do you mean by saturated vapor pressure?
Saturated vapor pressure is the pressure above which it
No, saturated vapor pressure, because whenever you have a particular liquid in a closed container, so there will be continuously vaporization will be occurring. That means there will be movement of particles from the liquid phase into the
gaseous phase.
gaseous phase or vapor phase. So there will be collision of these particles onto the wall of the container, and also they collide with each other. At a particular temperature, the amount of the particles entering into the gaseous phase and also entering back into the liquid phase becomes constant. And the pressure being applied, that whatever the pressure, vapor pressure, because of this bombarding, so that pressure is called as saturated vapor pressure. Now what actually, when you open nitrous oxide cylinder, the pressure gauge will be showing you the saturated vapor pressure. Whereas when you open oxygen, it is not the saturated vapor pressure, it is actually whatever the pressure of the gas that is there inside. So that is the reason your pressure gauge of oxygen will be showing you what are the contents, how much is the available content. What is the gas law that is applied here?
Boyle's law.
Have you known about universal gas law? What is universal gas law?
Universal gas law states that at a constant
No, it's the equation usually universal
PV is
gas.
equal to nRT.
PV is equal to nRT. So how do you apply this PV equals to nRT for this oxygen gas?
Here for oxygen gas, the
Now here,
temperature.
the volume, PV, volume is constant, isn't it?
Yes, volume
So
is
you can
constant.
take out that. The pressure is there on the left side. nRT is there. N is what?
Number of moles.
N is number of the molecules. R is what?
Is the coefficient.
Universal gas constant. Temperature?
Temperature remains constant. So
Temperature is all constant. So R is a constant, temperature is constant, volume is constant. So P is directly proportional to
the
N. So that's how application of universal gas law is very important in knowing that the pressure gauges of any gas will directly show the contents. Whereas nitrous oxide, because it's a liquid, it will be showing the same pressure till the last drop of nitrous oxide is there inside. isn't it? So now, which law I apply for knowing how much of gas is available for me if I want to use at 1 atmosphere with oxygen?
For oxygen.
Oxygen.
Universal gas constant.
Boyle's
law.
Boyle's law, isn't it? Because as the the volume I want to know, as I decrease the pressure, what will happen to the volume?
Volume increases.
Increases, isn't it? So PV is a constant. So now how do you calculate this? Just tell me the formula, equation.
P1 V1 is equal to P2 V2.
P1 V1 is equal to P2 V2. So with that, this is a 5 liter capacity cylinder. So
Pressure
how much usually, how many liters of gas when it is fully filled, that is 2000 psi?
660 liters.
Yeah,
of
roughly
oxygen.
660. You can even calculate. Suppose if it is 1000 psi is the pressure, how many liters are available?
330 liters.
Yeah, exactly half. So directly looking at the pressure gauge, you know exactly how much of oxygen is there. And suppose if I am using, so it is 330 liters, 1000 psi, and I am using 3 liters per minute. So exactly I know that I can use it for 100 minutes. So that's how it is very easy. Okay, so we'll ask her about the nitrous oxide. So because nitrous oxide is a liquid gas, so how do you know what are the contents available for me to use at 1 atmosphere?
It is based on the Avogadro's hypothesis.
Yes, very good.
It
What is
states
Avogadro's
that
hypothesis?
The 1 gram molecular weight of a substance occupies 22.4 liters at constant temperature and pressure.
Not constant. At standard temperature and pressure.
Okay, standard.
And what is standard temperature? What is standard pressure?
273 Kelvin.
Yeah, standard temperature is always 0 degrees centigrade or 273 kelvins. Standard pressure is 1 atmosphere. So at standard temperature and pressure, so 1 gram molecular weight, the molecular weight expressed in grams is called as gram molecular weight. So that will occupy 22.4 liters. Now let us say that this, how do you know how much of the weight of the gas is present, or weight of the nitrous oxide liquid is present inside? How can you check it?
Filling density.
No, you'll have to weigh the,
Weight of the
yeah, you'll have to weigh the cylinder, and
total
usually
weight of
on the cylinder, the tear weight will be there. Tear weight is nothing but the weight of the empty cylinder. So if just minus the tear weight, you get actually the weight of the liquid nitrous oxide that is present inside. So once you know the liquid nitrous, for example, I'll tell that it is 3.3 kgs are there liquid nitrous oxide in a fully filled nitrous oxide cylinder. Now how do I get this? How much of nitrous oxide vapor is available for me to be used?
That is 44. The molecular weight of nitrous oxide is 44.
Why 44? What is the molecular weight of nitrogen?
14.
14, very good.
14.
28 plus 16, so 44. What is the molecular weight of carbon dioxide? Carbon is 12, oxygen
16,
O2, isn't it? 32 plus 12 is 44. Almost, carbon dioxide and nitrous oxide have got similar properties. The carbon dioxide critical temperature is also about 35 degrees, almost very close to 36.5 of this. And its vapor pressure is also very close by. This is 750 psi, that is 800 psi. Because why you should know about carbon dioxide is also very important for us is, carbon dioxide routinely we use for lap surgeries. And in many of the anesthesia machines, and I heard even today in some of the machines, they have a provision for carbon dioxide cylinder, separate yoke is there. In older machines, we had a separate yoke for carbon dioxide was also there. Why carbon dioxide yoke had to be there? And 2,6 is the pin index of carbon dioxide. Why they wanted carbon dioxide to be incorporated?
To induce hypercapnia. To
No,
induce
one thing that also is very important. Sometimes you may have a machine where carbon dioxide yoke may be there. So better to know, because in those days ether was the most commonly used inhalation anesthetic agent for inhalation induction. What is the blood gas solubility coefficient of ether is 12. Blood gas solubility coefficient being high means, so induction and recovery would get delayed. So if I want to induce the patient faster, so I want to increase his alveolar ventilation. So if I add some amount of carbon dioxide, what will happen to the alveolar ventilation of the patient? It will increase. Carbon dioxide is a direct stimulant of respiratory center. So that's how, in order to induce faster, they used to use carbon dioxide. Even again at the recovery time, if higher alveolar ventilation is there, they can throw out the ether, so they can wake up early. So that's how carbon dioxide was also there. So that you should always remember. Okay, now for Avogadro's hypothesis, we have to apply for calculating how much it is there. And that you are calculating for at 273 Kelvin. So now how do you convert it into the room temperature?
Based on Charles' law,
Charles law, yes,
the
very
volume
good.
is proportional to temperature. That is V1 by T1 equals V2 by T2.
So because vaporization entirely depends on the temperature. Even the vapor pressure entirely depends on the temperature and does not depend on the atmospheric pressure. It is mainly on the temperature. If you heat up, the vapor pressure increases. If you cool the liquid, the vapor pressure will come down. So that you should always remember about some physics about these things. Okay. Now these cylinders have to be, tested, isn't it? So how do you test these cylinders? How they are tested? Because tested for tensile strength.
For tensile, we can use hydraulic testing.
Most commonly used is
Most
hydraulic
commonly used is
testing.
hydraulic testing. Other
Okay.
tests include impact test,
Okay.
bend test.
Hydraulic test is the most common, and many times there'll be in this it is not there. Sometimes you may be asked, there'll be a ring around just above the neck of the cylinder. So that ring where the date on which the hydraulic testing has been done would have been etched there. So that is, many times I have asked many of the students, they would not be knowing why that ring can be a plastic ring also, and majority of the times it is an aluminum ring will be there. So just remember about that. Okay, now coming to the yoke assembly. So what are the parts of the yoke assembly?
Yoke assembly, it has got a body, a retaining screw, a swell gate.
Okay, can you show here? Can show here. Okay. Okay, this is the yoke assembly. So I think people should know yoke assembly has been shifted onto the back of the workstation in modern workstation, whereas in the older machines it is on the sides. So this is the yoke assembly. You have a body, okay, and then what is this?
This is a retaining screw.
So this is the retention screw. What is this?
Swell gate.
Yes, swivel gate, very important, very good. So then something is there here.
That's a Bodoc seal.
Yeah, Bodoc seal. So this is the Bodoc seal. I think, I don't know whether you will be able to visualize. This is a very, very important thing, Bodoc seal. Okay. Okay. What is the purpose of this Bodoc seal?
Bodoc, it prevents a tight seal between the cylinder valve and the yoke assembly.
Mainly to have a tight seal,
Tight seal.
isn't it? So I still remember when I went to a nursing home when I was practicing, there was no Bodoc seal there. So when I opened the cylinder, it started leaking. So I searched for the Bodoc seal, it was not available. In front there was a cycle shop. So I got those rubber washers and then tried to fit. So every time I had to tighten it, they used to get worn off. So I had to postpone the surgery to get a Bodoc seal. So why this Bodoc seal doesn't wear off?
It is made of a hard rubber.
What is the rubber
name
that
is
is?
neoprene rubber.
Yeah, neoprene
And it has
rubber,
got
very
a,
hard.
Aluminum rim also
Yeah.
there. It
So-
makes it more stronger.
Yeah, wear and tear is very, very
Less.
minimal.
Minimal.
So it you can use it for a long period. Can I use 2 Bodoc seals?
No. It will nullify the pin index safety.
Pin index safety system is very good. So what are the other things? So there is here the pressure
Pressure gauge
gauge is also there. What is this pressure gauge?
Borden's,
called as?
Borden's pressure.
Borden's pressure gauge. So what is the basic principle with which the pressure gauge works?
Okay, it is made up of a metal tube, hollow metal tube of copper, and it is a C-shaped tube. One end is a blind end, and the other end is connected to a gas.
Okay.
As the gas flows, the
Tube straightens.
tube straightens, and it is connected
Moves
to
the
a
indicator.
indicator.
Okay.
It shows the pressure.
She can answer one of these. Okay. Now what is this?
This is a
You
yoke
can focus here. Yeah.
block. This
Yeah.
is a yoke block.
Yoke block.
It is used for. It is used to connect the pipeline to the yoke, hanger yoke.
Yeah,
assembly.
hanger yoke assembly. It is almost like looks like a
Valve,
cylinder valve. So you see the holes are there above and below. Why holes are there? And pin index holes, if you can see the pin index holes are there above and below.
So that even if you connect it in the
Yeah,
reverse
if you invert
direction,
it, and also you can
still
actually nullify the effect of
the pin index.
pin index safety system. That is the reason if you have holes above and below, even if you invert, cylinder you cannot invert and connect. But this you can definitely invert and connect. So this is yoke block. So there is something hanging here. some chain. Yeah, there is a chain hanging here. Can you see the chain hanging?
Yes, sir.
Yeah, what is this chain?
So chain for the yoke plug.
Yoke plug. Yes, very good. So why yoke plug? What is
So
the?
if the hanger yoke assembly is empty, without a cylinder, a yoke plug can be used to close the hanger yoke assembly. And this is very important because especially if the check valve assembly is malfunctioning, and it can actually lead to a gas coming out through this way, or it can cause transfilling of empty cylinders. So a yoke plug will actually prevent the above said disadvantages.
Okay. Now with modern workstations, I said that we have a separate inlets for pipeline connection,
Yes.
isn't it? So or they also have any pin index safety system like?
Yes, there's
What
a
do they have?
diameter index.
Yeah,
Diameter index safety system.
Yeah,
in
DIS it is called as diameter index safety system.
or the non-interchangeable screw threads.
Yeah, what is the difference between
seen-
DIS and NIST?
and DIS is seen in American-made machines,
Very
and
good.
NIST is seen in the British-made machines.
Okay,
In NIST, you have nuts that are of the same shape and size.
okay,
And
probes.
and the probes are of different shapes and size.
okay,
Whereas in diameter index system, you have two shoulders and two bows. So the shoulders are being connected to the bows, and that is indexed.
yeah,
And also all of these have specific color. It is color coded also, so that
the piping is color
the
coded.
piping is color coded. So you connect the correct gas to the correct
And
valve.
there also at the wall outlet also you have
Schrader
safety
valves.
systems are there.
It's
Schrader
Schrader
valves. They
valves
are,
or quick couplers.
yeah, why they are called as quick couplers? Why these are not called as quick couplers?
They're called as quick coupler because they help in easy coupling and decoupling, like
Yes.
easy removal. And
But here you just cannot do it. It will take more time, isn't it? So that's why these are, though they are also disconnections only, but they are called as Schrader valves or
quick couplers.
quick couplers. And the other important thing I just wanted to ask you is, how do I open the cylinder? For example, now she can answer. Suppose the cylinder, directly you connect the cylinder onto the machine, or you do something before
Cracking of the cylinder should be done.
cracking. What do you mean by cracking? You just crack the cylinder?
That is, before connecting the cylinder to the yoke, it should be slightly opened. This is to blow out the dust or the influent particles.
Yeah,
present.
because during transportation, that dust may be inside the port. So that has to be released. Otherwise, it can block the flow of gases, isn't it? So that is what is called as cracking of the cylinder. Many times you may be asked to open the cylinder. So if you are asked to open the cylinder, how do you open? Have you opened any time? Cylinder? Which one you open? You open the gland nut, or you open the spindle?
Spindle or the stem.
Spindle. That is because I still remember one exam center I went. So I asked every student try to open the gland nut. And when I asked the internal examiner, he said that we don't have to open the cylinder. Always we get the pipeline this thing, but it is not the thing. You should always know how to fix a cylinder, how to open the cylinder. All these things are very important. So many times what happens is the technicians will be doing these things, you may not be knowing. So that's how. One more question, the last question from my side is, how do you open the cylinder?
It has
And
to
what
be
happens if you open it fast?
done. It has to be done in a slowly.
How many turns you have to open these cylinders?
Slowly 3 turns.
3 turns, because it is a direct one. The indirect one, where the bulk cylinders and all, many of them can be of indirect type. So there, the 3/4 turn is enough. But here you'll have to open 3 minimum rotations for the port to be completely opened. So will you open it fast
No,
or very slowly?
If I open it first, the large amount of gas in a high pressure moves to a narrow area. It causes adiabatic process, or a heat energy is attained by that system, and it may catch fire.
Yeah, adiabatic process. What do you mean by adiabatic process?
When a large amount of gas goes through a constricted area,
Get compressed. A lot of heat energy is released. But this heat energy cannot be dissipated to the atmosphere. There is a change in the state of the gas, but because of this change in the state of the gas, energy is released, and this energy cannot be released to or dissipated to the atmosphere. So that large heat, that amount of heat can catch fire and explosions can occur. So that is the most important thing. And another thing is about the pressure regulators. So where are these pressure regulators? Can you show me the pressure regulator in this? I can open this. Where are the pressure regulators? So pressure regulators are also part of?
High pressure
Yeah.
system.
So what is the principle behind pressure regulator?
Basic principle, force equal to pressure into area.
Yeah, very good. Force is equal to pressure into area. Suppose if you increase the area, keeping the force constant, what will happen to the pressure?
The pressure reduces.
Pressure reduces. So that is a basic principle. Many times you will be asked, force is equal to pressure into area. So what happens here is the high pressured gases are made to enter into a large chamber, and the force is exerted by a spring from above, and that spring will produce a constant force. So force will not change. So naturally the pressure automatically drops. The outlet pressure will come down to 45 psig. So that is what is the pressure regulator. We have in many of the data accelerometer machines, we have a second stage pressure regulator is also there. So the principle behind second stage pressure regulator is also same. But why a second stage pressure regulator was required?
In order to convert a high variable pressure to a lower constant pressure to the flow meter, and in order to
For producing more accuracy.
for producing
As such,
more
pressure regulators themselves are a safety feature, so that you have a constant flow of gases through the flow meters. Even though the pressure in the cylinder may be dropping, but the outlet pressure from the pressure regulator is same. So whatever the pressured gases going to the flow meters are at the same pressure of 45 psig. So if you want more accuracy, you have a second stage pressure regulator that is there in the intermediate pressure system, isn't it? In data accelerometer machines, whereas in Draeger machines you have
flow restrictors.
flow restrictors. So slightly different. Bernoulli's principle is used there, isn't it? So that's about these things. And in older machines, especially the machines like this, the pressure regulator of oxygen and nitrous oxide, any variations? Master and slave.
Master and slave mechanism is there.
Okay.
So
So that is what master and slave. Unless the pressure of oxygen enters into the pressure regulator of nitrous oxide will not be released. So that is what was the master is oxygen, slave is the nitrous oxide. For the modern workstations, we don't have this master slave mechanism of the pressure regulator. They are simple pressure regulator. What else is there in the modern
oxygen
machines?
fail-safe valves.
Fail-safe valves. Madam will be discussing about this. So, Madam, can you go ahead with the intermediate pressure system and low pressure system? Or you can also sit also if you have mic plus. You can take that mic, Madam, for the time being. Yeah.
Now we have come to the intermediate pressure system. What is the pressure in the intermediate system?
For cylinders, it is 45 psig, and for pipeline, it is 55 to 60 psig.
What are the components in the intermediate pressure system?
Components include the pipeline inlet connection, the pipeline pressure gauge, the master switch, oxygen fail devices, oxygen failure alarms, auxiliary oxygen flow meters, oxygen flush, secondary pressure regulators, and the oxygen flush, and the flow control valve.
We have, so up to the flow meter valve is the intermediate pressure system. Now we have already discussed the pipeline coming into the machine and all that, so we'll leave that. Now we move on to the oxygen fail-safe valves. Can you tell us about oxygen fail-safe valves?
Oxygen fail-safe valves in data accelerometer machines are known as pressure sensor shut-off valve. While in Draeger machine it is known as OFPD, oxygen failure protection device. The pressure sensor shut-off valves is that when the oxygen pressures are less than 25 psig, it will completely closes the nitrous secondary gas entry. So when the oxygen pressure is more than 25 psig, it will opens the secondary gas entry, that is nitrous oxide can be used.
So it is a complete shut-off.
Complete shut-off.
At 25 psig, if it falls below that, There its a valve is completely cut off and there is no supply of nitrous oxide. Now what is it in the dragger machine?
The dragger machine, it is known as oxygen failure protection device. It when the pressures are less than 30 or 25, it proportionately decreases the pressures of the secondary gas and reduces the flow.
Now can you
at
tell us
less
some
than-
values, how it is proportionated?
When the the oxygen pressures are at about 25 psig, the pressures of nitrous oxide also reduces like 25 psig, and the flow is reduced. When the flow is less than 10 psig, it completely shut off the valve.
What is the other proportionating device that prevents hypoxic mixture going into the patient in the intermediate system? Now we talked about fail-safe valves. What is next, which will prevent hypoxic mixture going into patient?
Link 25 and the Link 25 in the dexometer machine, and a similar one in the Draeger machine is the
ORMC.
ORMC, the oxygen ratio monitor
Monitor
control.
control.
So in Link 25, what happens is it basically acts in this way. On the control knobs, you have a gear system, and these two gears are controlled by a chain, are connected by a chain, and that chain forms the link. And on this, you also have for the oxygen knob, you have a 14 tooth sprocket, 28 tooth sprocket, and for nitrous oxide, there is a 14 tooth sprocket. So this moves in the ratio of 2:1. That is, if nitrous oxide turns by 2 turns, oxygen will only turn by 1. So that is how the Link 25 system works. And also
But that is
because
only a ratio of 2:1.
2:1.
But we want to have the ratio of 3:1.
Yeah, that is where the
That
pressure
is 25, Link 25.
Yeah,
So
that
how
is-
does it?
Yeah, that is
work?
where the secondary pressure regulators come. So they have a differential pressure supply. For
good.
oxygen, it is 14 psig, and for nitrous oxide, it is 26 psig. So along with the differential pressure supply and the Link 25 system, a ratio of 3:1 is being, like 3 nitrous oxide and
Yeah,
oxygen,
very
1
good.
is being provided to the patient.
Even in the flow control valves are also slightly different for oxygen and nitrous oxide. More nitrous oxide will enter and less oxygen will enter through the flow control valve. So that's how overall 3:1 ratio is always maintained.
When is the Link 25 activated?
The Link 25 is activated when the ratio falls below 1:3. That is when the oxygen, it falls below 25%, the Link 25 system will get activated. Or when the nitrous oxide if you put a higher flow of nitrous oxide also, then still again to maintain that oxygen to nitrous oxide ratio, Link 25 will engage.
Okay, so it has to fall below the particular value before the system Link 25 gets activated. In other words, you can put oxygen independent of nitrous oxide however much you want. Okay. Now can you tell us about the
ORMC.
ORMC?
The oxygen ratio monitor control, it is present in the Draeger system. It is a pneumatic system which maintains a minimum oxygen concentration about 25%. When it has oxygen and nitrous oxide has 2 separate chambers which has a diaphragm, and this is interconnected by a movable shaft. And there are resistors in the flow meters for oxygen and nitrous oxide. And the oxygen resistor is more stronger. When the oxygen pressure increases, it creates a back pressure, and it opens a nitrous oxide slave valve, and thereby nitrous oxide flows. When the oxygen pressure decreases, it closes the nitrous slave valve and thus shut down the nitrous oxide flow. And also when the pressures in the nitrous oxygen increases, the back pressure increases and shuts off the nitrous slave valve, and thereby reducing the nitrous oxide flow.
So that is how the ORMC works. Now that is the system in the Draeger machines. Now when you have a machine, how do you find out whether it is the Link 25 which is operating or the ORMC?
In case of Link 25 system, if we turn on the nitrous oxide dial, the oxygen knob also rotates, so that we can understand that it is Link 25 system. So if we turn off the oxygen flow, the nitrous oxide flow also closes. And
Whereas in ORMC,
In ORMC, if oxygen flow is there,
Now, if I
then
open
only
nitrous oxide in ORMC,
it will not flow.
no,
No
flow
flow,
of either
nitrous
gas.
no flow of either gas there. If oxygen flow is there, then only nitrous oxide will flow.
Okay. What was the system in the older machines?
In the older machines, there was a master-slave system.
How was that different?
That was different because oxygen pressure was required for the nitrous oxide regulator to work and to release nitrous oxide. And how this works is like for checking, how we do is we have to switch on, like we have to open the oxygen and the nitrous oxide cylinder. And when we open the oxygen cylinder, then only the and then switch on the nitrous oxide cylinder, then only the flow will be there. But now, if after closing both oxygen, after closing the oxygen cylinder, and if we try to keep a flow, still
Flow of what?
Flow of nitrous oxide. The nitrous oxide will still flow. It will not flow because the oxygen or the high pressure system is closed. But keeping the high pressure system open, that is, if we turn on the oxygen cylinder, but and close the oxygen control valve, still the nitrous oxide will be there because within the system, the oxygen will be there because
So
of
you
the high
can
pressure
still
system.
give hypoxic mixture to the patient.
Yes, we can still
with
give
older
older
just
machines.
if you have master slave. So that's how another proportionating system was required. That's how your SORC, ORMC, Link 25 helps. Okay.
Now we come to the alarms. That is again to help you know whether you are giving hypoxic mixture. How does it work? And
The oxygen failure alarms get activated when the oxygen pressure goes below 30 psig. This is to enable the audibly and visually alert the anesthetist that the oxygen flow is reduced.
okay, what was it like in the older machines? What was the alarm systems in the older machines, and how was it different from the newer? How is it different from the newer ones?
Okay, in older machines, they used to have Bowman's or Ritchie whistle. It is purely a pneumatic whistle. When the oxygen pressures are,
You put off the timings, we'll continue for some time.
when the pressures are more than 30 psig,
We'll continue, no problem.
when the oxygen pressures are more than 30 psig, there is an oxygen canister there. It gets filled. When the system pressure, oxygen pressures are less than 30 psig, the valve from the canister to the Ritchie whistle opens, and the oxygen under pressure gets released through the whistle and makes sound until the oxygen canister get emptied. So that's a major drawback of Ritchie whistle, that the the problem may not have been verified by the anesthesiologist, but the alarm gets stopped.
So
No,
the
actually, the
oxygen.
mission standard requires that the alarm should continue
Should continue
till the another source of oxygen is being
connected to the
made available. Till then, it should continue. That is very important. So with modern machines, you have this. Okay, can you show 1 minute, madam? Can you show the alarm here in this? The old machine, but still you do not have the pneumatic alarm. Can you show the alarm here?
This is the electronic.
Yeah, this is the electronic alarm only in this machine also, because sometimes you may be asked, older machines will be kept. So this is the one is the electronic alarm. So what does it require? Now there is no electricity here. What does it require? How does it work?
What is it connected to, linked to?
Oxygen pressure.
No, you require battery,
Battery.
the cells.
Okay.
So if you open it, there are cells, because many of the time that is not changed from, because we hardly use this. If you open that, there are cells are there. You will have to, if the cells are exhausted, you have to put a new cells, then it starts working. So that is what it is always better for you to know that this is the electronic alarm that is there in the after some time, because this is not the very, very old machine. It is relatively newer machines, but this is not a workstation. Okay. And you have the hypoxic guard is also there here. This also has got the Link 25 in this older machine also. Afterwards, separately, they have added. Sometimes they may be asking you about this also. This is what is the hypoxic guard. So you can just show this. So this is also acts as a link 25. So just remember about this. Sometimes you may be asked, like this machine is kept MOSC, sorry, in MES, they may ask about, because this machine is going to be kept here. Okay. Right, madam.
Now we move on to the another important part of the intermediate system, the flush valves. Can you tell us what the flush valve is, why we need it, and
that also she can show the flush valve, oxygen flush.
Oxygen flush is over here in the newer system, and in the older system, it is over here.
how is it different?
The flush valve basically it is direct tubing from the pipeline or from the pressure regulator to the common gas outlet, and it basically gives high flow. So about 35 to 70 liters of flow is there in the
At what pressure?
of
What pressure?
45 to 60 psig.
Yes.
Comes at a pressure of 45 to 60 psig, and it
Does
is
it
placed
go
in a
through the
recess.
flow meters?
It does not go through the flow meter, so
Bypasses.
it bypasses the flow meter, so you cannot measure it over there. And the thing about it is placed in a recess, and it is like a button. So in the older machines, what happens is you could accidentally activate it, but in the newer machines, that facility, there has been a safety mechanism for that, so accidental activation of the flush does not occur.
And in the older machines, there was a locking system also was there.
A locking
So if
system.
you just push it and then lock it, your whole oxygen would be exhausted, because 70 liters per minute, you can imagine. So in just 5 minutes or 10 minutes, your whole cylinder will get emptied. That's how they have removed the lock in the newer machines and also in workstations.
That is, you push it once and it will remain like
Yeah,
that.
get locked. And in further Boyle's machines, Boyle's F, we used to have the common gas outlet here, and also, madam must have seen. So oxygen flush used to be like a lever. Just, bring the lever down, the flush will get activated. So that gets locked, used to get locked. That also quite a machine, that sort of a machine also may be kept for you in the exam. So you should remember that is slightly a different kind of oxygen flush.
What is the advantage and what are the disadvantages?
Oxygen flush is used especially when the mask ventilation is difficult, and there's a lot of leak between the mask and the patient's face. You can also use it to do the Petix test or to pressurize the system, or you can also use it for jet ventilation for partial or complete ventilation of the patient. Now, disadvantages of the oxygen flush is that it can cause barotrauma to the patient because it comes at such high volumes of about 1 liter per second. So it can cause barotrauma to the patient. And another thing is, since it bypasses the vaporizer and the flow meter, and a high amount of gas is coming, what happens is it can give, the oxygen delivered will be at higher concentration, and the inhaled gases and the nitrous oxide, everything will get diluted in it. So it can cause awareness in the patient. So that is one of the disadvantages of having an oxygen flush.
Now, how this problem of barotrauma is prevented in Draeger machines, some of the Draeger machines? Is there any special, precaution is there in that?
Yeah, in Draeger machines, they have something called the fresh gas flow decoupling valve.
Yeah.
And how that works is the fresh gas, it does not work during inspiration. So during inspiration, direct flow of gas to the patient is not there. And
so the gases are diverted to the back.
It is diverted.
Because it has got a piston type of ventilator. So when the piston creates a negative pressure, then only the valve will open, and the gases from the back are taken inside. And then next, when they are pushed back to the patient, the valve gets closed because a positive pressure is created. That is called as fresh gas flow decoupling system. And many times it has been asked as a short notes also. And you must have seen in Draeger machines, especially even when you have switched over to the ventilator mode, then also the bag will be moving. So you must have observed. So the bag will be moving in the Draeger machines because still it is connected to the ventilator pump, the direction of the gases. So every time the bellows goes down, they bring piston goes down, it gets the gases from the bag. So the bag collapses, and then again it So distance. So that's how sometimes you may be asked about fresh gas flow decoupling valve and system.
No. So I had already mentioned about second stage regulators and why is it needed. Now you can just briefly tell us where second stage regulators are there and what it does. Which machine has it and what does it do?
Second stage pressure regulators are present in the Datexometer machines. This is to provide a constant low flows to the flow control valves.
Plus the link 25. For working at the link 25. Pneumatic part of the link 25. Again, that's she was explaining about.
And what are the pressures brought down to?
And the oxygen pressures are brought down to 14 psig and the nitrous oxide 26 psig. This maintains the 1:3 ratio of the oxygen nitrous oxide.
What is left behind in the intermediate pressure system?
In dragger machine, there are flow restrictors are there instead of second stage pressure regulator. It works by the principle of
Flow resistors are
flow
there for?
restrictors. Dragger machine, there are flow restrictors are there before the flow control valve.
That is what sir was explaining. So what is the principle behind it?
It is based on the Bernoulli's principle. When the gas is going through a narrow space, its kinetic energy increases and the potential energy decreases. That means the velocity increases or the pressure reduces. So the air under lower pressure enters the flow control valve. The disadvantage is that it can vary. The output pressure can vary according to the fluctuations in the pipeline pressures.
Is it as effective as?
No.
Second stage pressure regulator.
It is not effective as second stage pressure regulator because second stage pressure regulator gives a constant pressure, but the output pressure in dragger machine, the flow restricted, can vary.
What is left behind now in the intermediate pressure system?
The flow control valves. The flow control valves is a part of the flow meter assembly.
Flow control knobs.
And it consists of the flow control knob, the stem and the seat. And the flow control knobs are color coded and touch coded. And for oxygen, the flow control knobs are large and this widely spaced fluids, and it is white in color.
Cylindrical.
It is cylindrical and it is white in color.
Yes.
And for nitrous oxide, it is small, conical in shape. The fluids are narrowly spaced and it is blue in color. Now,
that side air is also there.
yeah, this side air is also there. Here also it is small, narrowly spaced, and it has black
Conical
and white.
It is again conical.
Conical, and it has black. It shows black and white. When you turn the knob in the counterclockwise direction, the stem with the needle pin at the tip, it will move away from the seat and it will allow the flow of gases to the flow meters. And when you turn it in the clockwise direction, the stem with the pin will go and fit into the seat, and it will close the it will shut off the flow to the flow meters. So then
On either side there is a stop is there.
either side a
You
stop
cannot
is also
overturn
present.
it. That is another safety feature of flow control knobs.
Now we have come to the low pressure system. What are the components of low pressure system?
It has the flow meters, it has an indicator or bobbin or float, and the scales with the graduations.
How is the flow meter assembly divided?
For if the gas has two flow meters,
Flow meter assembly.
the oxygen should be in the downstream.
Flow meter assembly is divided into sub-assembly and
Flow meter assembly consists of a flow control valve, and the flow meter sub-assembly consists of flow meters, the indicators, and the scales. And the flow meters,
and after that, what are the other components of low pressure system?
you have the back bar with the vaporizer, check valve, pop-off valve, and the common gas outlet.
Okay. What is the pressure at which the gas comes out of the common gas outlet?
It is just above the atmospheric pressure 7 to 8 psi.
Can you tell us about flow meter assembly, sub-assembly?
It consists of the flow meters are consisted of a glass tube, which is of
The
top type.
difference between this machine and the workstation, the flow meters.
In this, the oxygen has got 2 glass tubes are there.
Yeah. You can show here and there again.
In older anesthesia machine, it has got only 1 tube for 1 gas, and here it has got 2 tubes for 1 gas.
Each gas.
Each gas.
Okay.
So that means the lower flow, we can accurately give lower flows using modern anesthesia workstation. When one gas is having 2 tubes, that means it is single tapered tubes. Then the anesthesia machine, there is only 1 tube for 1 gas. That means it is double tapered.
Now, why there has to be a separate tube for low flows?
In order to give accurate low flow.
Because we practice now low flow anesthesia technique. So when you are practicing low flow anesthesia technique, you have to have an accurate flow. With this, you cannot have an accurate flow. For example, if I want to give 250 ml of oxygen and 250 ml of nitrous oxide, very difficult to adjust with this. So if you have a separate flow meter for a low flow, where every reading is quite widely placed, you can exactly give that accurate amount of flow. That's why that is again a safety feature that has been adopted in modern workstations. Separate flow meters for high flows, separate flow meters for low flows.
Now, if it is so accurate, why can't we have a narrow tube for the whole thing?
Then it would be the length of the tubes will be very high. So in order to prevent that, we are selected a single 1 tube for lower flows and the other tube for higher flows, and the gradation will be
No, they are tapered, isn't it? They are tapered. Why they are tapered is because in order to decrease the length.
To decrease the length.
Yeah, that's why these flow meters are called as what type of flow meters?
So,
No, the Thorpe is
Variable orifice.
Variable orifice. The orifice, the annular, the orifice around the bobbin keeps on increasing. It keeps varying. So that's why variable orifice, fixed pressure, because the pressure drop across the bobbin is same
constant.
at whatever the position of the bobbin. So variable orifice, fixed pressure, flow meters. That's what they are called as.
And it also has bobbins or indicator. It has made of aluminum, and it has got a wider rim at the top, and the level of when the bobbins, we measure the gas flow from the top of the bobbin,
Upper border.
upper border of the bobbin, and it has got slanted flutes are there. So when the gas passes through the flutes, it rotates. That
Makes the bobbin to spin.
it makes
So
the bobbin.
rotation is very important to know that the gases are flowing.
Okay, and also there is a fluorescent dot is there in the bobbin. It indicates the gas is flowing.
Yeah, especially when you are operating in a darkened room, for example, laser surgeries, or even in the radiology department where the light will not be there. So the fluorescent dot will be showing you that the bobbins are rotating, the gases are entering. So with modern workstation, anything else is there for you to know that whether the flow meter, the bobbin is rotating or not. Lights are there. In modern workstations, you have a lighting of the flow meter assembly will be there, so that you can just put it on and then see whether the gases are flowing or not. In the older machines, what is this backing? There is some backing is there. It's a fluorescent backing. Because of the fluorescent backing, even in darkened rooms, you can see the bobbin rotating. Not only that fluorescent dot, the fluorescent backing, that on the back side of the flow meters, what you see is a fluorescent backing. So it will give you an indication whether the bobbin is rotating or not. Those are also again the safety features that sometimes will be asked for you.
Can you tell the
Anti-static material can also be sprayed on the tube in order to prevent
Sticking of the
sticking
bobbin.
of the bobbin
What
to
is
the
that anti-static material? That
crock
is
steel.
crock steel. It is sprayed inside. Okay.
now to what are the principles behind the gas flow in
The
flow meters?
The principles, they basically, at low flows, the gases act by the flow acts by the Hagen-Poiseuille law, where it depends on the viscosity of the gas. And at higher flows, it acts by the Graham's law, where it is dependent on the density of the gas. So at
Because low flows is laminar flow.
laminar flow.
Higher flows, it is
flows,
artificial or
turbulent
turbulent
flows.
flow. Okay, why this turbulence occurs?
The turbulence occurs because the annular opening increases as we go higher, as we go for the higher flows.
Now, what happens to the Reynolds number? Reynolds number.
It increases.
Yeah,
it
Reynolds
increases.
number, once it crosses more than 2000, the laminar flow gets converted to turbulent flow. Because the velocity increases. Once the velocity increases, because the Reynolds number is velocity into density into diameter divided by viscosity. Viscosity of the gas will not change. Velocity increases. So the Reynolds number crosses 2000. So the flow becomes turbulent in higher flows. The density is very, very important for the amount of flow that is going out of the flow meters. So why should you know about this? Viscosity for lower floors and density for the higher floors.
It is important because when it comes to calibration of the system, especially in higher altitude places, this comes into play. At higher altitudes, the density of the gas will decrease. So when the density of the gas decreases, more like even if we set a high flow, a flow that is higher than that will be delivered to the patient,
Yes,
resulting in hypoxic mixture being delivered to the patient. That
For
is why it
example,
is
which
important.
gas will flow more, we don't know. Whether nitrous oxide may flow more than oxygen, then hypoxic mixture can get delivered. If oxygen flows more than nitrous oxide, then awareness can
Awareness
occur.
can occur.
So these have to be calibrated at that particular atmospheric pressure.
Atmospheric pressure.
Are you not worried about viscosity at high altitudes?
We are not worried about viscosity at higher altitudes because it does not change at higher altitudes.
Okay. Now, if there is a crack in the, say, where should ideally be the oxygen flow placed in the flow meter?
Oxygen flow meter should be kept downstream to all the gases.
Why?
Because if there is a crack,
Suppose I'll tell you a situation where oxygen is upstream, then you have air and last nitrous oxide. Now there is a crack in the sender tube, that is air. What can happen?
the oxygen can flow to the air also. So the concentration of the oxygen getting to the patient will be less, whereas the nitrous oxide, the flow is not affected. It will be going directly to the patient. So it can lead to hypoxic mixture delivery to the patient.
Suppose I have the oxygen downstream. What is the advantage? If there is a crack in the sender for the air, and I have the oxygen last downstream, and first it is air.
The flow of there will be difference
Air is in the sender, let's say. The crack is in the air.
there will be difference in the flow of the nitrous and air, and it will not affect the flow of the oxygen.
Hypoxic
And the
mixture will
hypoxic
not
mixture
be
delivery
delivered.
will be prevented.
Now suppose there is a crack in the oxygen flow meter, what can happen?
Hypoxic mixture delivery to the patient will be there.
Okay. Can you summarize all safety features in the flow meter assembly?
The flow meter assembly, first from the flow control knobs, it is color coded and touch coded, and it has got a guard there, and there are stops which stops at complete closure or maximal opening of the knobs to prevent damaging the fine needle valves. And it is color coded, and it is also written there oxygen, nitrous oxide and air. And the flow meter tubes, it has got bobbin which has got fluorescent dots which indicates rotation, which rotates, indicates the gas is flowing through the tube, through the system. And we can easily give accurate flow at the lower flow rates. We can
And you have anti-static material is also
anti-static
there.
material
Those
as Proxtin.
sticking
which
of
prevents
the
sticking
bobbin
of
will
the
not
bobbin.
occur. So these are some of the safety features.
Now we have come to the back bar. What is the safety system in the back bar?
The back part has a check, the pop-off valve and the check valve. So
What
the
about
pipe-
vaporizers?
For vaporizers, we have the selector tech, which prevents two vaporizers being used at the same time. So only one vaporizer can be used at a time. So
Okay, and then about these?
the check valve and the pop-off valve. Now, the check valve, if there's any obstruction, it can damage the vaporizer and the flow meters. So in order to, that happens if the check valve is malfunctioning.
And also your pumping effect, pressurizing effect. When you are ventilating, you are going to create a positive pressure. That positive pressure will also go to the vaporizers. And that can produce a pumping effect and pressurizing effect. So alter the amount of vapor coming out. So in order to prevent that, what you have is, this is
The pop-off,
the
the
check
check
valve.
valve.
Check valve.
And when the pressure increases above 5 psig or 300 centimeters of water, the pop-off valve will vent off the excess gas.
Okay, okay.
Do you have check valve in the newer workstations?
Check valves are present in the GE Omeda machines, but it is absent in the Rega workstation.
That brings us to how we are going to check the system with the check valve in place and without a check valve in place.
We have two leak tests, positive leak test and the negative leak test. The negative is the universal leak test. The positive pressure leak test, how it is done is, we obstruct the common gas outlet, we pressurize the system up to 20 centimeters of water. Pressure system to up to 20 centimeters of water, and if there is no leak, the pressure remains constant up to 10 seconds, minimum 10 seconds. If there is a leak, the pressure drops. But in the case of the direct stomata machine, since we have the check valve, the leak in the system can be checked only till the check valve. Whereas in the dragger machine, they doesn't have the check valve, so the system can be checked till the downstream to the nitrous oxide. And the negative leak test, that is a universal negative leak test. That is, we connect a suction bulb to the gas outlet, we collapse it completely and see if it remains collapsed for at least a minimum 10 seconds. If there is a leak, the bulb inflates. If there is no leak, it remains collapsed. It can be tested in the presence of check valve or
That's why it's called as
universal
negative
leak test.
Universal leak test.
In your opinion, what is most important to provide a non-hypoxic agent to the patient and to look after a patient well?
An oxygen monitor, it's oxygen.
Where do you have the monitor?
Oxygen sensor.
Oxygen sensor, and we have to.
And you have to be there.
We have to be vigilant.
Now, oxygen sensor should be as close to the
As close to the
gases
common
that are
gas.
delivered to the patient, isn't it? So, oxygen sensor is the most important thing to know whether hypoxic mixture is being delivered to the patient or not. And whatever it may be, it is the man behind the machine is more important than anything else. It is you who is more important, because a lot of safety features may have been adopted, but still there are incidences of mishaps. So because of the negligence on the part of probably the anesthesiologist also. So it is the man behind the machine is very important. So man should know everything about the machine, then only he can use it better, and the safety of the patient can be looked after, isn't it? Yeah, thank you so much. Thanks for sitting and then listening to this discussion, because initially it was for 1.5 hours only. I only requested it, 1.5 hours students may not sit. I said that we'll reduce it to 1 hour. Now, since so many of you are still sitting, we got so much of encouragement. I told Madam we'll continue for another half an hour. So thank you so much for patient listening, and it was very good thing. Thank you, Madam. And your students answered fantastic, really, absolutely no problem. You have prepared them very well. So congratulations to each one of them and to you also. Thank you, Madam.
Thank you, doctors, for the wonderful session. For everyone's kind attention, an important announcement regarding the bus timings. There are going to be 3 buses. The first bus will leave by 9 p.m., the second by 9:30, and the third by 9:45. I repeat, 9 p.m., 9:30, and 9:45. Location will be same as yesterday, the security check post. Thank you.